applying linear graphs. So, rules and graphs can be used to help analyze many situations in which there is a relationship between two variables. So, if we have a rate of change of one variable with respect to another, we have a straight line graph. So, for example, if I had a pile of dirt being emptied out of a pit and that pile of dirt increases at a constant rate, in this case 12 tonnes per hour, then the graph of the mass of dirt over time would be a straight line, because for every hour the mass of dirt increases by 12 tonnes. So when something changes with respect to something else, we have a straight line graph. So let's see what this looks like in terms of some examples. So having a look at this, a hiker walks at a constant rate of 4 kilometres per hour for 4 hours. So that's important, 4 kilometres per hour for a maximum of 4 hours. And it says draw a table of values using T for time in hours and D for distance in kilometres. And I've set up the table to start with. Now I'll just put a little X and Y here to remind you that that is X and that is Y. Now at time 0, we haven't gone any distance, so the distance is 0. And it's telling us how far we travel. We travel 4 kilometres every hour. So after 1 hour, the hiker is 4 kilometres away. After 2 hours, they are 8 kilometres away, and then 12 and 16. And now we're asked to graph this. Well, we've been doing this a lot. 0, 0, 1, 4, 2, 8, 3, 12, and 4, 16. And we join our dots up with our lovely straight line, and it looks like this. So we all know that the equation of a line is y equals mx plus c. But in this case, my y-intercept is 0, so y equals mx is all I'm looking at. To find m, I have a look and see what is that change in y doing, and it's actually going up by 4. So my gradient is 4, y equals 4x. And now I really need to get things back in the correct terms, because instead of x, I have t, and instead of y, I have d. So now I need to rewrite this as d equals 4t. And I can now label my line d equals 4t. So I've found my rule. This is the answer here. Now, once you have a rule, we always use this rule to answer any other questions. My rule is d equals 4t. And we're asked to find the distance when I've travelled 2.5 hours. So d equals 4 times 2.5, and I get 10. And it's kilometres because I've gone 10 kilometres. Use your rule to find the time taken to travel 8 kilometres. Well, same thing. It's always the same rule. D equals 4t. Now I'm told D, which is 8, equals 4t. And we would divide both sides by 4. And you would get t is 2. So it would take 2 hours. I know you could do this without even writing the rule out, but I want to show you with a simple example how we can come up with our answers. Let's have a look at the next question. If you'd like, you might want to pause the video and have a go first. If not, you can follow along after. Okay. The initial volume of water in a dish in the sun is 300 millimetres. So initial is at time 0. The water evaporates, so it gets less, and the volume decreases, going down by 50 millilitres per hour for 6 hours. And it says draw a table of values using T for time and V for volume. So, drawing up my table, I'm going to draw up one big table. And instead of X and Y, I now have time and volume. And we're looking at our time from 0 to 6, 2, 3, 4, 5, 6, because we're going to a maximum of 6 hours. So now I'm just going to finish off my table. I'm nearly done. Okay, now to fill it in, let's see what's going on. The initial volume, so that's at time is 0. I filled up my water in that dish, so there's 300 millilitres in there. After 1 hour, it's reduced by 50 millilitres, so I've got 250 millilitres. After 2 hours, another 50's gone, so I've got 200, and so on. You can see the pattern, it's going down by 50. And what have I done? I've forgotten 4, haven't I? Let's fix that up. 4, 5, and 6. And I get down to 50 and to 0. Now, draw a graph. Well, to draw a graph, I'm going to need 2 straight lines. There's one, and there is my other one. Now, instead of X and Y, I've got V. This is the volume in millilitres. And along the bottom, I've got time. This is T in hours. Now, you should be using a ruler and use a ruler for every centimetre. You can draw a dash and put these numbers in. And same for volume. I'd go every centimetre, and I'm going to start with 50 and go up in 50s. And yours is going to look so much better than mine. Now, we do know a sneaky rule. We don't need to plot every point because we've learnt about just the X values and the Y values. We know when time is 0, the Y-intercept is 300. And we know from here the X-intercept is 6. And once I have 2 points, I can join them up with my straight line. Now, this graph doesn't have arrows on either end because we're only looking at it from time 0 to time 6. So we're not looking at a graph that goes on for forever. So I don't put arrows on there. Write a rule linking V with T. Well, we know that Y equals mx plus c. My gradient is what is happening here, which is it's going down by 50. So my gradient is negative 50. And my y-intercept, we can see it here, and we have it here as well, and that is positive 300. Now, to fix it up, I really need to use it in terms of T and V, and I can see that T and V are here. So now I'm going to swap it around, and instead of Y, I'm going to write V equals negative 50 T plus 300. And now we're going to use our rule to answer some questions. Use your rule to find the volume of water in the dish after 4.2 hours in the sun. So V equals negative 50 T plus 300. V equals negative 50. Instead of T, I have 4.2 plus 300. And then we work that out using our calculators, and I get volume equals 90 millilitres. And now we're going to do exactly the same for the next one. We write our rule out, V equals negative 50 T plus 300. Now we're trying to find the time because we are given the volume. 75 equals minus 50 T plus 300. So to solve this, I'm going to subtract 300 from both sides, and I get 225 equals negative 225 equals negative 50T. And so we're going to divide both sides now by 50. Let's have a look at what that looks like. Divide by, I should say, negative 50. And I get time is 2.5 hours. So 2.5 hours. Thanks for watching.